Dear students, good morning. Today we will do some problems. We'll solve some problems in Unit 2. So now we'll take this sum. Consider a point-to-point link connecting LAN in a separate building across a freeway of distance 25 mile with the line of sight communication in a unlicensed spectrum minus 802.11b at 2.4 gigahertz and the maximum transmit power of 802.11 is 24 dBm. The minimum received signal strength RSS is for 11 Mbps operation is minus 80 dBm. Will the signal strength be adequate for communication? So this is the question. So the question is, consider design a point-to-point link connection LAN is in a separate building across a freeway of a distance 25 mile with a license with a line of sight communication in an unlicensed spectrum, and maximum transmitted power is 24 dBm. The minimum received signal strength is 11 Mbps. Operation is minus 80 dBm. Will the signal strength be adequate for communication? So this is what we have to find out. So solution. Given it is line of sight and the distance is 25 mile, which is approximately. So receiver sensitivity and threshold is given as minus 80 dBm. And received power is given by, we know the formula, PR is equal to PT minus path loss. So now PR is equal to PT minus path loss, 21.98 plus 20 log to the base 10 of lambda minus 20 log 10d. So this is the formula. In this we have to substitute 24 minus 21.98 plus 20 log to the base 10, 3 lambda value I am substituting, 2.4 into 10 power 9 minus 20 log to the base 10 of 400. So I have substituted all the values. Now I am calculating it. 21.98 minus 18.06 minus 52.04. So this will be equal to 24 minus 92.08, which is equal to minus 68.08 dBm. So from this calculation, the power received is well above the required minus 80 dBm for communication at the maximum data rate. So this dBm is sufficient for a communication. This is what the conclusion. Dear students, hope you understand. Okay. So the next sum is For example, in a multi-carrier system, B equals, let us say, about 10 megahertz and number of subband n equals to 1000. Calculate the bandwidth per subband and symbol time in each subband. So this is the question. That is, in a multi-carrier system, B equals say 10 megahertz and the number of subbands equals n, which is equal to 1000. Calculate the bandwidth per subband and symbol time in each subband. So now we will see about the solution. So what else they are given? They are given B is equal to 10 megahertz and n is equal to 1000. So according to the formula, bandwidth of each subband is B is equal to subband will be equal to B by n, which is equal to 10 into 10 power 3 by 1000, which is equal to 10 kilohertz. Another one, what they have asked, symbol time in each subframe is T equal to 1 by P by N, which is equal to N by B, which is 1 by 10 kilohertz, which is equal to 0.1 millisecond, or you can say 100 microsecond. So these are the two examples which is given for you. Rest we'll see in the next video. Thank you.